Hello, this is Mr. Stansbury. I'm going to take you through the notes on nearest neighbor interpolation. At the end of this, you should be able to say, I can use interpolation on a Voronoi diagram to estimate unknown values. Okay, so first things first, interpolation. Interpolation is a form of estimation of a value from certain known values. For example, estimating a value from a graph where the graph will actually hit that point is interpolation. So like when x is 5, 1, 2, 3, 4, 5, y is about 2. Okay. It's not going to talk about this in here, but like later on, like there's also something called extrapolation where that's outside of the data. So if we were to say, you know, this is 6, so let's say at 8, what would it be? It'd probably be like at about 1 or something like that. That's extrapolation, but we're just worried about interpolation for now. There is the nearest neighbor interpolation, which is estimating the value of a variable at any point by using the nearest known data point. So, for example, the estimated populations of shoebill storks in a town in Africa are measured by game trail cameras in 7 different locations as shown by the map. The population results are shown in the table. Use the nearest neighbor interpolation to estimate the stork population at these different spots. Okay, so at 4, 2, let's see. So here's our, if you'll notice, here's our X and our Y. So at 4, let's see, let's find a good color that we'll be able to find. I guess we'll use this dark blue. So we'll at 4, 2, we're right here, right at, oh, that's 1. Sorry, so at 4, 2, we're right here in D. So D has a population of 40, so we're going to assume that that's going to be pretty close to 40. Okay, let's write that with a color that you can see better. So that should be probably pretty close to 40. Okay, and then with B, we're at 2, 4. Okay, so if we go 2, 4, we are right here, and that is in the B region here, which we officially call the cell, so it's in the B cell. So B is at 22. Okay, we only have 2 left, and this is all we have for our notes, so we better pause for a quick comedy break.
This is parkour.
Okay. Let's see. Let's check and see what happens at 1, 1. So at 1, 1, ooh, look, we're right here on one of the edges. So what we do for that is we're going to take the average of G and F. So that's 16 and 19. And there's 2 of them. So we add 16 and 19, divide by 2. That is what, 35 divided by 2, which gives us about 17 and a half. That does not look like a 17. There we go. About 17 and a half. All right. Okay. And then at 1.5 and 3. So 1.5 and 3. Oh, look at that. That's right at a vertex. So if it's at a vertex, you take the average of all of the adjoining cells around it. Okay. So we would do A, B, and G. So we've got 18 plus 22 plus G is 19, and there were 3 total. Okay, so we add those all up and divide by 3. So we do 18 plus 22 plus 19, and we get 59. Divide that by 3, and we get 19.7. That'll get us about 19.7 if we round it off. Okay, and that there is the nearest neighbor interpolation. Okay, if you have any further questions on any of this, please feel free to ask. Thanks.